Okay, this is Mr. Peterson. I'm a math teacher, Algebra 2 specifically, at Gardner Edgerton High School in Gardner, Kansas. And I want to share with you a creative use I thought of for the graphing program Desmos. You'll find it at desmos.com. It's a Google product, so it's widely available. Okay, so we're going to specifically learn how to compare and simplify expressions, and we'll also solve equations. And this will provide a way for your students to check their work and to get immediate feedback, especially in the early stages where they're just learning different skills. So, a little bit of training on Desmos is required when you do this with students. So, I'll show you a little bit myself here. In the top right corner of the Desmos screen is a wrench. You'll see it above the plus and minus sign on the top right. And if you click on that, you want to choose, it'll come with a small font size. You want to go with a large font size, and that just magnifies the X and Y axis numbers to make it easier to read. Then you're going to do what Desmos does best. You're going to graph a function. So I'll put in a linear equation here. Y equals 1 divided by 2, x plus 3 here. And you get that linear equation graph there. So the kids need to know how to type in a fraction with the divide key. One of the strengths of Desmos is its editing functions here. And so what I want to do is show you that you don't need to put in the y equals. It will assume that. So we're going to treat this instead of an equation, a function equation, we're going to treat it just as an expression. 1 divided by 2, hit the right arrow, then the x plus 3, and you'll see you get the exact same equation. The same graph on the right. That's the key, is the graph doesn't change. Now, this is only possible because Desmos assumes you forgot to type the y equals. In other words, it's pre-programmed to supply that information. It assumes you're trying to graph a function. Now, if you tap on, in this case, I have a green or in a red circle on the equation lines here. If I tap on that, it turns the graph off and on. The kids need to know that. And so I'm going to turn both of those graphs off and move on to a new one here. And I'll teach you how to type in exponent. So let's say you had a parabola. Y equals, I'm going to leave the y equals off, 2x, and you hit the shift key and the 6 key to get the caret. That's a pretty typical way of getting the exponent going. Then right arrow and then minus 3. And so you get your parabola there. Okay, I'm going to turn that one off. I'll simply hit that little green circle with, it looks like a sine wave there. And I'll do an absolute value function. Kids might need to know this one. ABS, and then a parenthesis, and your expression x minus 2, and you've got your function. This is actually not the way you'd normally see it, so I'll show you the other way to do it here. I'm going to delete that, and I'm going to go down to the bottom left of the screen, and there's a keyboard icon. And on that keyboard, when you call it up, there will be an absolute value function. It's on the bottom left over there. It says absolute value of a. And now you can just say x minus 3 or whatever you choose. And if you continued typing here, plus 1 here, you would get your V-shaped graph that you're used to when you graph absolute value expressions. Now, rational expressions can be typed with parentheses if you have a complicated numerator. Let's do x plus 4 divided by x minus 3. And you've got that expression. I'll turn both of those graphs off, and I think I've got an extra line there. Ignore that last line. So that's what I wanted to do on the general training part of this little tutorial. And now I'm going to show you some examples of how I intend you to learn to use it. So a beginning algebra student might be learning the distributive property, and they've got this expression here, 1/2 times the quantity 2x minus 8, and they want to do their work and find out immediately whether they're doing it correctly or not. So I'm going to go to example 1 here, and you can see that I have the original problem written there, and the student then would type the second line. Actually, I'm going to type it without the y equals, and you'll see that there's really no need to put the y equals there. This is the expression that was originally given to the student, and you can see that it's the same as the other line above it, so I'm just going to delete that top line. I'll do that by hitting the little gray X to the right of the expression, and so now I have essentially the same graph. So the graphing calculator Desmos is assuming that I'm graphing the function y equals that. So the student then would type in 1/2 times 2x. Their second line of work would be 1x minus 4, and you can see it's the exact same graph, and that's how they know they've done it right. Well, let's kind of simulate an error here. Let's pretend they forgot to distribute the half to the back half of it. You can see that it gives a different graph, and they know immediately that they've done something wrong, and they can experiment. And once they get one graph to fit right over the top of the other one, they know they've done that step correctly. Okay, here's another example of that. This time with a little bit more work, we're taking the top expression. We've got 3 lines of work here, and one of the things I'd like to point out is that the students actually have to do the work, which is a whole lot better educationally than just pointing their phones at it and using some of these apps like PhotoMath or otherwise. So now what I'm going to do is click on the other version of it. And I've already typed it out here, but you can see that the original problem graphs is that blue parabola. And I'm going to turn on this next one here. It turned green, and it's the same path. So I know that line is correct. And then the answer looks like that. Now, there's a lot of typing, and that's one of the disadvantages of this method. So I'm going to point out right away that you could simply type the top one, or the original, and then to check all of your work at once, you type the bottom line and see if the graph is the same. Then if there's problems, you can go back and troubleshoot by typing the intermediate lines. So I'm going to just show you an example of a mistake you might make. Experience tells me that a lot of times when students distribute a negative number, they forget to multiply the negative times the other negative. So -4 times -5 should give +20, but if you type -20 there, you can see that the graph changes radically, and it must not be an equivalent expression. So we'll fix that, and now we've got that one correct. Okay, let me give you some more examples here. Example 3, excuse me. We're supposed to write this expression in standard form, and what I've got right here in this first section is a common mistake. People distribute exponents, which gives them the wrong answer. So I'm going to simulate that on Desmos, 2x squared plus 3x, and then I've also got the correct version typed in, so you'll see that in a minute here. Example 3. So the second line represents the mistake, and so if I tap on that, you'll see that the graph changes, and you know it's wrong immediately, that something is wrong there. So the student says, well, I got that wrong, and if they figure out, oh yeah, we're supposed to multiply the expression 2x plus 3 times itself, then they can delete or erase that incorrect work and simply check it as they go by typing these lines. Now that is admittedly a lot of typing, so once the students have gained some skill by getting this immediate line-by-line feedback, then you just train them to type in the first line and the last line, and then they've got confirmation that all of their work is correct. Okay, the next example here is an equation, and this is a little different on Desmos. It's not a function, there's no y value in this, and Desmos really just jumps to the answer and says x equals 7, but because it's a graphing calculator, you're going to see this as a vertical line. So let me go to example 4 and I'll show you what I mean here. So here's example 4, and I've got the original problem written there. And sure enough, on the graph, you're going to see that vertical line at x equals 7. And when I light that up and it turns green, you know that, yeah, that is the right answer. But you can actually see the answer ahead of time. So the student has their work confirmed. They already know what their goal is. They're trying to get an answer of 7. And when they get down here and they light that up and it's the same graph both times, they know that they've got that done right. Okay, I've got a couple more examples here. Example 5 is a little more complicated. This is one in which the work actually branches. By the time you get down to the second line, you've got this plus or minus that we typically on paper write as one flow of steps. But Desmos has to kind of separate these, so I'll show you a few of those. You can see the first side is done here, and that's using a positive sign in front of the square root. To get the other sign, you have to use the negative sign, and I'll highlight those, and you can see that highlights that other answer of -1. So it's a little unwieldy here. This is actually a lot easier to do on paper, but truthfully, what the student could do, I'm going to simulate that right now, is just type in the original problem and the answers light up right away. They'd be aware that there were 2 of them. One of them is the x value 1 unit to the left of the origin. That's x equals -1. And then to the right of 5, a couple units over, you see x equals 7. So they know the answers right away, and they can check their work that way. Okay, so let me go back and look at the next problem. Here's one in which there's some factoring involved. And towards the bottom, it splits up. So we end up with 3 answers, 0, 3, and -5 halves. And because it splits up, it's more difficult to type on Desmos. So I'm going to suggest to you on this next example here, let me find it first, that you simply do the top part and check it, either all 4 lines or just check the 4th line, and you can just read the solutions off the graph there. One of the lines is x equals 0. That's the middle one. And then there's x equals 3 and x equals -5 halves. So a student would be able to confirm their work by just typing 2 lines. Okay, a couple more examples here. Let's see here. That was example 6. Yeah, actually, I just have them typed on Desmos. Give me a second here. Example 7. What this is just a computational problem. It's essentially using Desmos as a calculator. So it's an area of a triangle with a base of 30 and a height of 45. And you can see the work there. You got a consistent answer of 675 all the way through. Now, the letter A is just an arbitrary choice, but it makes sense if you're looking for area. If it's not an X or a Y, though, you won't get any graph. Here's an example from calculus. And what I have is the original function f of x, and then I'm going to paint what I think the derivative is. And then I'll use Desmos derivative feature with that little prime mark on it, and you can see that it's the same graph. So I think with this example, you can see that there's a lot of possibility with this technique. And it does have its problems. It does involve typing, and especially at the younger ages, people might not be willing to do that, and you certainly wouldn't want to do all this work if you were proficient at it. But you can just, as I showed on a couple of those examples, type the top line and the bottom line and see if your answers are correct. So it gives you a way of checking your answers and knowing whether they're correct without doing the work for you. So that is it for my presentation. And I hope this helps you as you train your students on how to do algebra and be good at it, because they get this constant feedback. If you're a student reading this, then maybe you understood enough to be able to just do it without a teacher guiding you through it. Desmos is actually quite easy to learn if you haven't used it before. And you could give me some feedback in the comment section below there. It's not a perfect video, but I sure hope it helps you. All right, this is Jeff Peterson signing out from Gardner, Kansas, and y'all have a sweet year.